In this video, we're going to discuss types of reactions. Now, any given reaction is just a chemical reaction, but there are commonalities of certain behaviors that mean that if we know what we expect the change to be in a reaction, we can predict what the outcome will be. So types of reactions are just sets of common tools that we can use to help us predict what's going on. Things like combustion. Combustion is burning, having things react generally with O2 on Earth. Though technically you can combust with other materials. That is generally what we think of on Earth. If you've got a carbon material, like CH4, and you burn it with O2, well, we predict that you're going to get CO2 and you're going to get water. As a general rule, this is the outcome of any hydrocarbon burning on Earth. You might get a little carbon monoxide. If you've got a little contamination with sulfur or nitrogen in your source of your hydrocarbon, then you could get a few other compounds too. But as a general rule, hydrocarbons will burn like this. You'll need to balance it to find out exactly how much, but we're going to make carbon dioxide, water, and some heat. This is just an easy way, an example here where we can predict the outcome regardless of what it is we're putting in, as long as it's within this class of hydrocarbons. There's other types of reactions, precipitation reactions. Precipitations have some chemical that is aqueous and another chemical that is aqueous. You end up combining them to make a solid material. So if we expect there to be a precipitation reaction, we need to be aware that we're going to make a solid. If whatever device or process you're working on doesn't have a way to clear a solid out that settles to the bottom, you're rapidly going to run into problems as you clog your device. And so knowing you have a precipitation reaction dictates how you have to create whatever it is you're building to handle that process. So precipitation reactions form solids as a result from things that were not solid to begin with, usually aqueous solutions. There's also redox, reduction-oxidation reactions. These are reactions that move electrons. So you could have Fe2 plus and you add some zinc, and afterwards you have zinc 2 plus and iron. You've changed which thing is positive and which is neutral. You've swapped electrons from the zinc to the iron. Redox reactions happen all the time. In fact, a great deal of reactions are also redox reactions. Combustion involves movement of electrons and repairing between different atoms. It is also a redox reaction, not just a combustion. Precipitation, on the other hand, doesn't change the charges. This might have been X plus and Y minus. There's still those charges afterwards. So if electrons are moved around, it is also a redox reaction. But not every reaction is a redox reaction. You can have things like decomposition. A decomposition reaction has something that breaks down. N2O4 can break down into two separate NO2s. One large thing collapsed into two smaller things. Explosive is often a decomposition reaction. One large molecule like TNT breaks into a bunch of different nitrogen and carbon dioxides and the like. Well, simultaneously you can have combination. Two separate things can combine. Carbon monoxide and dihydrogen can combine to form formaldehyde. So depending on whether you're sticking things together or having something break apart, these are reactions as well. Decomposition tends to end up in more things, combinations tend to end up in less things. There's also displacements. You can have AB plus C react to become AC plus B. Whatever compound C is can come up and displace B off of the other compound. Well, this can also be a double displacement. You could have AB and DC become AC and DB. In this case, instead of having one thing that was on its own that decided to find a partner, which happened up above, you have things that swap their partner. B and C swapped what they were paired with. Depending on certain elements, they tend to pair better with other counter ions. And so you could have things that one might like a chloride, one might like a fluoride, and so you put them in solution and they will swap the chlorine and fluorine to the element that wants it more. This also works with sulfurs and oxygens and all sorts of other things. There's plenty of times where an element tends to pair better with a different second element, and so if it has the opportunity to swap out a less desirable partner for a better one, it will. If both materials have this, then it's just a double displacement reaction. So here's a few examples of the ideas of types of reactions. They're all just chemical reactions. We're swapping what elements are paired with what other elements. However, they tend to follow certain predictable paths. Hey, I'm going to make a solid. I'm going to make carbon dioxide and water. I'm going to swap where my electrons are. I'm going to have more particles or less particles afterwards. Knowing the type of reaction or types of reactions that we're working with can help us to plan exactly what products are going to come out or what type of reactions need to come in or what devices we might need to deal with the materials.